Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 1, Lesson 10, Translating English to Algebra. Before we begin, let me remind you that the worksheet that's used for this lesson and a homework set can be found by clicking on the video's description. As well, don't forget, on the corner of each worksheet we have the QR code that goes along with the video. So scan that with your smartphone or your tablet and it'll take you right to any of our eMath instruction videos. Okay, let's begin. The dreaded word problem. So often in algebra classes, you need to translate English into algebra. Now, this isn't too bad as long as you know a lot of terminology and you know your order of operations inside and out. So what we're going to be doing today is just getting a lot of practice on the terms and on how to interpret things. Listen closely, try to follow along, and get practice where you can, okay? So let's jump right into exercise 1. It's important to be able to recognize addition and subtraction in phrases. First, let's begin with some numerical work and then transition to expressions that contain variables. Letter A says write a calculation and a result that represents a number that is 5 greater than 3. 5 greater than 3. Now it's kind of interesting because of course addition is commutative, so it really doesn't matter which way you write it down. But technically speaking, a number that is 5 greater than 3 is this. Ooh, and I'm in green. So that's 3 plus 5, and of course the result is 8. I think I'm going to go back to blue. I think you can see it better. Now you might say, well, I wrote down 5 plus 3 and got the same thing. But technically speaking, a number that is 5 greater than 3 is 3 plus 5. The key word there is greater. All right? Now that's important because when we look at letter B and it says write a calculation and a result that represents a number that is 2 less than 9, it is very important that we do not write down 2 minus 9. In fact, a number that is 2 less than 9 will be given by 9 minus 2. That's the expression. What it's equal to is 7. So 2 less than 9. It'd be very easy to think, I should just put down 2 minus 9. But 2 minus 9 is negative 7, right? Now, there's nothing wrong with negative 7. It just isn't a number that is 2 less than 9. All right. Now, letter C is a little bit easier. Write a calculation and a result that represents the sum of negative 3 and 8. The sum of, that just means we're adding them together. So really there, negative 3 plus 8 or 8 plus negative 3 would work. Either way, we have a result of 5. Letter D, write a calculation and a result that represents the difference of 20 and 12. Now again, when we're talking about a difference, that's subtraction. And we have to go in the order that the numbers were given. 20 minus 12. The difference of 20 and 12 will be 20 minus 12. Again, the result is 8. All right, now we're going to transition to variables where it becomes way, way more important. But what I want us to do is to keep looking back at what we did in A through D because it's going to mimic what we had here. Letter E, if x represents a number, write an expression that represents a number 10 greater than x. Well, if we're at x and we want a number 10 greater than it, then that's going to be x plus 10. Make sure you're not writing down 10 plus x. Are they equivalent? Yes. But a number that is 10 greater than x is just x plus 10. Letter F. If n represents a number, write an expression that represents a number that is 5 less than n. Again, this is absolutely critical. A number that's 5 less than n, well, if I had n, then I'll subtract 5 to get a number that is 5 less than n. All right, letter G. If y represents a number, write an expression that represents the sum of y and a number 1 greater than y. Okay, so we're adding. What are we adding? We're adding y and a number 1 greater than y. So that's going to be y plus 1. All right, so the sum of y and a number 1 greater than y. I don't want to do anything else with that. It can eventually be written as 2y plus 1, but all I'm looking to do here is translate, not simplify or anything else. All right, letter H. If n represents a number, write an expression that represents the difference. The difference, key word here, the difference between a number, 1 larger than n, and a number, 1 smaller than n. Well, here's a number, 1 larger than n. Here's a number, 1 smaller than n. And here's the difference. Now, it's not quite right though. Anytime we're talking about a more complicated number, it sure doesn't hurt to put it in parentheses. And in fact, in this problem, it's absolutely essential. This is very different than this. Well, maybe not very different, but slightly different. This is n plus 1 minus n minus 1. This is n plus 1 minus n minus 1. All right, parentheses are key. Parentheses are key. Okay, so I really want you to think about what we did in those exercises, especially in G and H with the parentheses use. Very, very important. All right, and I am going to clear out the text, okay? So, copy down what you need to, pause the video. Here we go. All right, let's go on to exercise 2. Now, we need to be able to deal with addition and subtraction, no question. And addition and subtraction have words like sum, difference, greater, less, things like that. But we also need to be able to deal with multiplication and division. So let's look at a little bit of that. Exercise 2, letter A. Write an expression for a number that is 5 times greater than 2. Write an expression for a number that's 5 times greater than 2. Well, 5 times greater would just be 5 times 2. Now, the actual number is 10, but it didn't actually ask me to do that. That's a number that is 5 times greater than 2. Letter B, if n represents a number, then write an expression for a number that is twice n. Well, twice n means that we're multiplying by 2. So that's just going to be 2 times n. Same thing, 5 times greater than 2, twice the number. Here it gets a little bit tricky. Quotient or ratio, right? That's division. Division, very important. Write an expression for the quotient or ratio of 12 and 3. Lots of different ways we could write this. We could write it with the little colon notation. We could write it like this. But the most appropriate way is to write it with a fraction bar. That's the way that you're going to see it 9 times out of 10 in algebra. So anytime you see quotient or ratio of blank and blank, the first one goes in the numerator, the second one goes in the denominator. That's just convention. It's just the way it is. So letter D, it says if x represents a number, write an expression for the ratio of x to 5. Well, simple enough. X divided by 5. Okay? Lots of space in that problem that I probably didn't need. Anyway, at least it gives me somewhere to put my head as opposed to the last problem. Always an issue on these screencasts. So I'm going to clear out the text, pause the video if you need to. All right, here we go. Okay. Next exercise. Translate each of the following statements into algebraic expressions. So now these are going to become a little more complicated. Okay? We have to think about order of operations and keep in mind that multiplication and division will always occur before addition or subtraction unless you somehow circumvent order of operations, so you get around order of operations by using parentheses. Okay? So let's take a look at letter A. If x represents a number, then write an expression for a number that is 3 more than twice the value of x. So we want a number that is 3 more than twice the value of x. Well, 3 more, that's going to be addition. Twice the value of x, that's going to be multiplication. So Unless otherwise told, we should do that multiplication first. So there's twice the value of x, and there's 3 more. All right? Not 3 plus 2x, but 2x plus 3. 3 more than twice the value of x. Letter B. If n represents a number, then write an expression for 2 less than 1/4 of n. All right, 2 less than 1/4 of n. Well, again, 1/4 of n can be thought of as either division or multiplication. I think I'm going to keep with multiplication. 1/4 of n is 1/4 times n, and then 2 less means we're subtracting 2. That's really important because in terms of the wording, the 2 less comes first. But when we find 1/4 of a number and then something that's 2 less than it, we will find the 1/4 first. Okay? Letter C. If S represents Sally's age and her father is 4 years less than 5 times her age, then write an expression for her father's age in terms of the variable S. Okay, so wait. Her father is 4 years less than 5 times her age. Well, her age is S. 5 times her age would be 5S, and 4 years less would be minus 4. So there it is, 5S minus 4. Letter D. If x represents a number, then write an expression for 3 times the sum of x and 10. Now this is interesting because I want to do 3 times, that's easy enough, the sum of x and 10. So I want to add x and 10, that's the sum, and then I want to multiply by 3. Please note, that's not the same as 3 times x plus 10. Right? These aren't the same. Here, this would be 10 more than 3 times x. This is 3 times the sum of x and 10. All right, real important, those parentheses. Okay, pause the video if you need to write those down. All right, I'm going to clear it out. Gone, and continuing on. Let's keep doing it. So the more of this translation we work with, the better it will get. It can be tough though, okay? Keep at it. What I'd like you to do in these last 4, they're not the last 4, but in the next 4, is to try them on your own. So pause the video now and see if you can do a little bit of translation. All right, let's do it. Letter E. If n represents a number, then write an expression for 7 less than 4 times the difference of n and 5. So we're going to find the difference of n and 5. We're going to multiply it by 4, so that's 4 times the difference of n and 5. And then we're going to have 7 less. Wow, look at that. That is definitely tricky. 7 less than 4 times the difference of n and 5. Let's look at letter F. If x represents a number, then write an expression for the ratio of 3 less than x to 2 more than x. Well, all right. Here's 3 less than x. Ratio means division. So the ratio of 3 less than x to 2 more than x. Here we go. Right? X minus 3 divided by x plus 2. Letter G. If x represents a number, then write an expression for the sum of twice x with twice a number 1 larger than x. Okay, so we're adding some things. What are we adding? We're adding twice x, that's easy, with twice a number 1 larger than x. Well, here's a number 1 larger than x. And here's twice that. Really important on the parentheses, and then I'm going to sum them together. So there's that sum, there's twice x, and twice a number 1 larger than x. Again, we could simplify that, but nothing in the problem tells us that we have to. Let's take a look at letter H. If n represents a number, then write an expression for the quotient, again, division, of twice n with 3 less than n. That's not so bad. Here's twice n with 3 less than n. All right. Wow, some of these are quite complicated, like letter E and letter G. F and H, not so bad. But E and G, especially E, look at that. All right, well, let's clear this out and attack the last two in this particular problem. Here we go, I'm going to scrub it. All right, 2 more. Translate each of the following statements into algebraic expressions. Again, I'd like you to pause the video right now if you haven't already tried letter I and letter K. You know, one wonders why I left the letter J out. Weird. Apparently I just don't like the letter J. Anyway, translate each of the following statements into algebraic expressions. All right, so pause the video and take a shot at it. All right, let's go through it. Number 3, letter I. If y represents a number, then write an expression for 3/4 of the difference of y and 8. Well, the difference of y and 8, that's pretty easy. That's going to be 8 minus y. Now, if I want 3/4 of is a good word to look for when it comes to multiplying, right? So when we say 1/4 of, or 1/2 of, or 3/4 of, we're multiplying. So we're taking y minus 8 and we're multiplying by 3/4, 3/4. All right, let's look at letter K. If x represents a number, then write an expression for 1/2 the sum of x and 4. All right, well, the sum of x and 4 is easy enough, x plus 4. And then if I want 1/2 of it, I'll just have that. Likewise, we could just do this, x plus 4 divided by 2. That's also a good way to do it, but kind of sticking with the last problem. I think that makes some sense. All right, so watch for that word of, right? Sometimes it means multiply, sometimes it doesn't, as in this situation, right? The sum of x and 4. All right, I'm going to be clearing out the text, so pause the video if you need to. All right, let's get rid of it. Moving on. All right, the last problem, we're just going to play around with a pattern again. See if we can see some structure in a problem, little pattern coming out that we might be able to prove algebraically. Exercise 4. Neat patterns can occur repeatedly when you play around with numbers. A fairly easy one occurs when you add a number to one less and one more than the number. All right, so let's make sure we understand what we're doing. When you add a number to one less than the number and one more than the number. Do this for a few numbers x and record the results. Then prove a general pattern by writing an expression for the sum of a number with one less than a number and one more than it. So watch, let's grab a random value of x. Let's go with 5, okay? And what this pattern, what we're looking for is 4 plus 5 plus 6, right? A number less than it, a number one more than it. 4 plus 5 is 9, plus 6 is 15. Let's go with a different number. Let's go with, I don't know, 8. So then we'll have 7, a number one less than it, plus 8, plus 9, a number one more than it. 7 plus 8 is 15, plus 9 is 24. Okay? I'm not sure I see the pattern yet. Remember, what we're trying to do is think about how the 5 relates to the 15, how the 8 relates to the 24. Let's go with another one. Let's go with 10. a number 1 less, 9, plus the number 10, plus a number 1 more, 11. 9 plus 10 is 19, plus 11 is 30. And why not? One more. The calculations I was supposed to put down here, but I just totally ignored it. I don't know. Let's go with 20. Why not? Number 1 less, plus 20, plus a number 1 more. 19 and 20 is 39, plus 21 is 60. So what's the pattern? It looks like we always get 3 times our original variable, or 3 times our original value, right? 3 times 5 is 15, 3 times 8 is 24, 3 times 10 is 30, 3 times 20 is 60. So here's how we'll do it. We'll let n be our number. That's simple enough. So then what we're doing is we're taking a number 1 less than it, plus the number, plus a number 1 more than it, right? Now, we don't really need these parentheses here. We can remove them due to the associative property, not the associative property. Then we can use the commutative property to start rearranging things. N plus n plus n plus -1 plus +1. Those 3 put together will be 3n, and these put together will be 0. So there it is, right? We will always get 3 times our original number. And that's kind of neat. We can see that in the pattern. Okay? So let's clear out the text and wrap this one up. All right, so today we worked at trying to turn English into algebra, specifically turn English descriptions of algebraic expressions into algebraic expressions. This is going to be critical as we move forward and we look at a variety of word problems over the span of this course. So work on it hard, make sure you do that homework, and you'll get better at it, I promise. All it takes is hard work, but every single person can get better at math if they just keep practicing at it. All right, no matter how weird it may seem. Okay, well, thank you for joining me for another Common Core Algebra 1 lesson. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.